This conference will now be recorded.
Okay, a warm welcome to all the participants and a very good morning to you all. Happy to see you again in this webinar. So, first of all, introduce myself. Yeah, this is Pratap studying BTech final year in the stream of Electronics and Communication Engineering from Mekapati Rajamohan Reddy Institute of Technology and Science. So today we would like to conduct a live webinar on smart manufacturing and Industry 4.0, which is organized by the Department of Electronics and Communication Engineering from Mekapati Rajamohan Reddy Institute of Technology and Sciences. Under the cooperation of our principal sir, Dr. M. Manoj Kumar Reddy sir, and our HOD of EC department, Mr. N.V. Subba Reddy sir, as well as our convener of this event, Mr. A. Dastagiya sir, assistant professor in EC department, and our co-convener of this event, Mr. P. Raja sir, who is the assistant professor in EC department. And now it's time to speak about our speaker, Mr. T. Narendra Reddy sir. For that, I would like to read a small profile of him. Yeah, presently, sir working as a scientist at Central Manufacturing Technology Institute, CMTI, in the Department of Smart Manufacturing and Precision Machine Tools. And sir completed his MTech in Mechatronics Engineering from National Institute of Technology, Karnataka, NITK. And also, sir has 11 years of industrial experience in precision machine developments and IIoT solution developments and development of nano precision machine elements and development of scanning tunneling microscope STM. And sir received 2 national awards from FIE Foundation in the year 2013 and 2019 for the product exhibition at IMTex 2013 and IMTex 2019. And thanks to all the participants for coming and join with us. Hope this event will be successful with your presence. And it's time to invite our speaker T. Narendra Reddy sir to take the session.
Good morning, Pratap.
Sir, yes sir. Audible sir. Good morning sir.
Good morning, everyone. Myself, Narendra, working as scientist in smart manufacturing and fusion machine tools at Central Manufacturing Technology Institute. Firstly, I'm thankful to the college for inviting me to give a talk on smart manufacturing and Industry 4.0. Coming to the contents of my presentation, first I will be talking about what works I have carried out at CMTI. The main purpose of giving this presentation is to give a exposure and also to bring the curiosity to the students what a scientist will be doing in a research organization. And the second topic is on conversion of legacy machines to smart. This topic, again, it is a very important topic for our Indian manufacturing industries, because most of the manufacturing industries in our country are 60 to 70% of the machines are 25 to 30 years old. Now the challenge here is how to convert this old machines or legacy machines into a smart machine. That is the second topic. The third topic is smart manufacturing development and demo cell, what we are having at CMTA, what we do, and it is a national initiative on smart manufacturing. The basic objective again here is to propagate this smart manufacturing and industry 4.0 to industries, and also bring awareness to academic institutes to work on smart manufacturing. The fourth one is basically the videos about smart manufacturing. The last topic is on basics of smart manufacturing and other important technologies around this smart manufacturing. You'll get to know the terms and the other aspects. These are the nature of duties what we do at as a scientist in organization. The first one is we work on R&D projects. Basically, we work either on a product or on some technology to be developed or some process needs to be developed. Then we also need to offer services to the industries. That way you will be serving to the industries as well. The third one is whatever knowledge we gain, that has to be disseminated. That's why we try to conduct training programs and we share our knowledge. And whatever research we do, that we try to publish it in international conferences as well as journal publications. Then apart from this, we need to also work on sophisticated imported machines. Those new technologies, we try to bring it to the country, we learn and we operate, we provide service to the industry. These are some of the products what I have been developing for almost 11 years. Totally 7 products I was associated to develop. The first one is related to the nanotechnology instruments, that is nano positioning stage, and the second one is a scanning tunneling microscope, and the second technology on nanometric motion systems, where I'm involved in development of hydrostatic slide as well as aerostatic spindles. The third important one is development of ultra precision machines. The beauty about these machines are there are only 2 manufacturers in the world to make this kind of machines across the world. We are the third manufacturer who had developed these machines in our country. And all these technologies are first time in the country. Okay, whatever we are working here, this is these technologies what I was associated, all are first time in the country, and it goes the tremendous challenges while developing this. And the beauty about this CMTA especially is we have a team of group where we work, where the knowledge from electronics, electrical, computer science and mechanical, we work as a multidisciplinary team. That's why we could able to develop all mechatronic system in the country. And I will not be talking about each technology because it takes a lot of time. Only one technology I will be talking, that again it is related to this intelligent aspects, and you will be appreciating what that technology is about. And also if you know the value about that product, then you will be much appreciating the technology as well. This machine, if you buy it from other country, it would cost somewhere close to 5 to 6 crores. This basically, this is an ultra precision machine. We call it as diamond turning machine. I think mechanical department is also attending people. They will be knowing what is a turning machine. Basically, normal turning machine, you get accuracies of 2 to 5 micrometers surface finish. And when it comes to geometrical accuracies, again, it is close to 5 microns, you get it. But when it comes to this machine, we get surface finish as well as form in terms of nanometers. Okay, we get a finish down to 5 nanometer. And then when it comes to geometrical accuracies, we get about 100 nanometer. Okay, let us go to the applications. Coming to the applications, if you why this machine is very expensive, it is because the elements what we use it all are frictionless motion systems. Okay, this frictionless motion system provides nanometric motion, and also it will not have any thermal deformations. That way you get accuracy in terms of nanometers. And this machine, basically what you can produce is you produce metal mirrors, and also you produce mirrors related to brittle as well as ceramic materials. And if you look at infrared camera, the basic heart of infrared camera is the lens. That lens is made out of silicon and germanium. This they use it for night vision applications. If you look at our requirement, for us mobile is a very important device today. How it has become very important. Without mobile we don't move out from the house. Likewise, for a soldier, night vision camera is very important. Otherwise he will become blind. He cannot he cannot fulfill the purpose what he is supposed to. That way we have a huge requirement for night vision cameras. Okay. And coming to the second, metal mirrors for astronomical system. Those metal mirrors you can produce using this machine. And then we have ophthalmic. Almost 70% of the lenses. You talk, I'm saying if you want. No, you talk. No. India is about 60 to 70% of the contact lenses, whatever is producing across the world. India is producing 60 to 70%. Those molds you can produce in this machine, and in turn you can make this contact lens for just 30 to 40 rupees. And I think those who had gone for cataract surgery, your parents or somebody's old age people, they would have spent 15,000 rupees for the lens, but actually they can produce within 25 to 40 rupees in this using this technology. And you can also produce ultra precise mechanical components. If you want to develop something like hydrostatic bearings or aerostatic air bearing elements or aerostatic elements, you can produce using this machine, as it can produce nanometric accuracies. And if you look at defense and electro-optics applications, you can make head-up displays using this machine. And when you go to high-end cars, you can see light reflectors. That also you can make molds, and in turn you can produce in mass. And for photonic applications, you can produce micro lens arrays. And when it comes to display systems, again you can make a molds, and in turn you can mass produce. And coming to the energy application, you can make Fresnel and diffractive lenses on a silicon. In turn, it will increase the efficiency of the solar energy. And then coming to the metal mirrors, if you look at it today, lasers are used in various applications. To guide the lasers, you need to have a metal mirrors. All these metal mirrors, whatever they use it for, laser micro machining or laser welding, so many sophisticated systems, they use these metal mirrors for guiding the lasers. Moving forward, that is about applications of ultra precision machine. And one module I wanted to talk, where you need to understand where artificial intelligence will be used in machine tools, and also how computer science students and then electronics will be part to develop a single module. This is a simple software module what I have developed, that is a thermal error compensation for ultra precision machine tools. If you look at any component which is coming out from the machine, there are only two aspects you need to look at. One is the component accuracy, what you are getting it, the quality of the component. When you keep producing that component, you will never get the repeatability within 5 microns. Most of the times, if you go to any production environment, they try to say that my whatever values I mention on the job, it will be somewhere close to 5 micron repeatability. It shows that there is the error of 5 micrometers on the component what you get it. But the challenge here is now we wanted to control the repeatability within 1 micrometer for a whole day production. This component, it takes 5 minutes to produce. Likewise, in 1 hour 12 components, in 24 hours we may make somewhere close to 300 components. When I make 300 components, the component size should not vary within 1 micrometer. That is the challenge. Now how to address it? For the reason why we get that 5 micrometer error in any machines is that is due to thermal error. There are so many errors which occurs on the machine. One could be geometrical error, one could be thermal error, but thermal error is the major contributor for the component accuracy. About 70% of the component error what you are getting, it is due to thermal. Now we have taken a module where we wanted to correct that thermal deformation errors. Why the thermal varies? Because it varies due to external environment like the weather. It can varies with respect to the season and the machine where it has been put. So many factors. It is one of the challenging problem for a researcher to correct these errors. But we made an attempt to develop a module. What we have done here is we have mounted temperature sensors across various elements of the machine, and we also mounted displacement sensors on the machine. That way temperature sensors are measuring temperature, and deformations or displacement errors are coming due to the using capacitive sensors. What we have done, we have extensively almost 30 to 40 days data we have collected by varying the environmental disturbances. We wantedly created the disturbance so that we can generate the data. We have created a huge set of data. Here one point I wanted to highlight. We always feel that Facebook, WhatsApp and many other software players, they give you free everything. The reason why they give everything free is they want to collect the data. Actually today's world, data is business.
చేసి తలుపు చేస్తాను సరే కానీ ఇంగ్లీష్
If you have data is nothing but money. Okay, now data is business. Okay, they all these big companies, MNC companies, they try to collect the data from individual person so that the data can be used for their models and finally come out with a business models and give it to the concerned people. And the second one, in our case also, the key is data. For me to collect this data, I have almost 40 days with the different conditions. We simulated and we collected the data, and using that data, we have used neural networks. These neural networks, it will take both temperature as well as corresponding deformation. Using training algorithms, it will iterate and finally look for, it will able to train in a best possible method, and finally you just give the input as temperature, it can able to predict the deformation how much it can come. And this is the modeling what we did in using MATLAB. And once we have done, and once a neural network has been trained comfortably to the performance what I have expected, then we need to implement this in a controller so that the machine will be doing the job what it is supposed to do without any thermal deformation. The second what we did here is we have written, in order to run it very fast, you need to write a program in either C or something like Python. Then the program will be very faster because it is a text-based programming. We have written a program in C program and finally integrated to the machine, and finally we validated that module is working. That is, initially we were getting around 50 micrometer. It is again simulated condition, we could able to compensate down to 3 micrometer. And finally on the component, we have worked almost for almost 6 hours. The component is not varying the size. That shows that this module is without any human intervention, it is correcting the thermal deformation. doing. And these are the services we do to the industries. Here we have supplied metal mirrors to SAC Ahmedabad. We have supplied some micro lens arrays to DRDO labs. Then we have made some precise components to Department of Atomic Energy. And these are some of the publications what I have done. And this, whatever products we develop, we doesn't keep it in the laboratory. We try to take it to the exhibition and we try to receive either comments or appreciations in the, we try to exhibit in the international exhibitions. Okay, very few organizations will be doing this kind of activity, because showing your product to the across the world is a challenge for Indian community at least. And in 2013 we have displayed this intelligent ultra precision turning machine, and we got the first FIA Foundation award. And in 2015 we have taken two equipments. One is the aerostatic spindle and nano positioning stage. In 2017, three products we have taken, that is again scanning tunneling microscope. This is a high-end microscope where you can do nanoscale imaging that we have developed. And then we have developed the aerostatic spindle. This is again first time in the country. None of the Indian companies could able to develop this kind of precise spindle where the running accuracies will be less than 50 nanometer. If you see normal turning machine or turning spindles, it will have an error of 5000 nanometer. But whereas here you get only 50 nanometer error. When I make a circle, that is a perfect circle what human can draw. If I put a pen and make to rotate, I will get a perfect circle. And here this is a hydrostatic slide where it can move in terms of 1 nanometer, and it can take a load of 1000 kg. And this 1000 kg you can move with finger. Okay, there is no friction between moving member and the static member. And these are the two machines what we exhibited in 2019, that is NanoShape 250. Again we have received FIA Foundation award. And the last technology what I have displayed is how to convert one more technology, that is how to convert a legacy machine into IoT enabled smart. Okay, with this my introduction is over about the work what I have done. In summary, what I want to say is, if you want to develop a very good product, you need to have a multidisciplinary team. And in your college also, if you want to make a new product, let you people collaborate between departments, and you can make a beautiful product. And of course, if you see again Industry 4.0, it is a combination of mechanical, electronics, communication, then IT. Then you need to have a dashboard developer where computer science students can do that. That way you can make a beautiful solutions in the college itself. And one more beauty about this Industry 4.0, it is an easy catching technology. Okay, you don't need to have sophisticated equipments. You don't need to, because the internet web is freely available now, and then the sensors are freely available at a cheaper cost, and the electronics whatever you buy from a local market, again it will be very few bucks you can get it. And you can do very simple solutions like energy monitoring at for the college or your department or for your home. You can do many things. Okay, with this my first topic is over. If you have any questions, I would be happy to answer. Pratap,
Sir,
should we ask questions at the beginning or later?
sir, at the end of the session, sir.
Okay. The second topic is how to convert these legacy machines to IoT enabled smart. As I mentioned that in Germany, almost 100% of the machines are connected to each other. What does connection means? The machines communicate to the systems, and the robots will communicate to the system. It means you can exchange the information between your mobile or computer to the machine. But in India, only 2 to 5% of the machines are connected. It means that whatever is happening on the manufacturing floor, You don't know what is happening without any manual intervention. But that how to address, we will see that. Before we getting into that, let us understand one more important challenge here is we in India, we cannot directly getting into a modernized laboratory just like that. The reason is it be due to economy. We cannot develop a manufacturing company which is industry 4.0. It requires huge investments, but there are a lot of manufacturing companies in the country, but all those manufacturing companies wanted to get into this industry 4.0, but the limitation is all those machines are 20 to 30 years old. Now the challenge here is they are interested to get into industry 4.0, but the technical challenge is how to make them industry 4.0 ready. Okay, that way you can get real-time visibility of your operations, what is happening in the factory. If you can make these old machines somehow get the data, and then you can pinpoint what activity is going on, how the production is happening, what kind of maintenance is required, all that we can address. And if we can able to do that, we can able to save 70% of the capital. That way industries would be very much happy to collaborate with academic institutes or research organizations if we can provide a solutions. Okay, now let us go how to convert this old machines into new. This is not very tough to do it. There are only 4 ways wherein you can convert old machines into IoT smart. Either you fix external sensors, you buy a low cost IoT sensors or normal sensors, and then put it on the machine, and somehow you gather the data. The second one is there are some requirements where they wanted huge information from the machine. Then there will be limitation with respect to the old machines. In that case, what you have to do is you have to change only the drive or motor or controller. Altogether you can change. That way you can get a full information about the machine. If your requirement is something, you have a hardware and still you wanted to collect the information using the same hardware, there are some intelligent gateways are available. Using these intelligent gateways, you can convert the protocols whatever way you want it. There are protocol converters are available. Those people, we call it as intelligent gateways. And we have video cameras. If your requirement is basically to monitor the production, or you wanted to measure something, then you can use video cameras and you can monitor it. This way you can able to convert old machines into IoT smart. One is using external sensors, one is changing hardware, only the electronics part, not the mechanical, because mechanical elements can work for longer duration, something like 30 to 50 years it can work. And in some cases you don't want to invest anything, then you just buy some intelligent gateways and push the data to the computer. And in other case, you just only want to monitor the production or you want to measure something, then you use video cameras. Most of the applications, these 4 solutions will work, and you can provide the solution to them. And how we can do this? This is one demonstration what I have made to demonstrate to the people how to convert. I have taken a very old machine, and there I have mounted the temperature sensors 300, and we connected the LEM current sensors, and we connected accelerometer, and we connected the pressure sensor, we connected the video camera. Here the basic objective was to show all the possible solutions in a single module. Okay, that was the objective. Then this you can use it for thermal behavior, this you can use it for energy monitoring, this you can use it for health monitoring of the machine, and pressure you can use it for any alarms like that, pressure monitoring. And computer vision we have integrated for measuring the component accuracies, whatever the part which is coming out from the machine, that part is okay or not, that report also generate using this computer vision. This is the demonstration. You can see here. Here, 4 modules we have developed. One is the machine thermal behavior, and the second one is the spindle health monitoring. The third one is energy monitoring. The fourth one is the part quality check. In this, you can see that I have mounted temperature sensors across the machine. Based on temperature sensors, how much it is deformating in the X, Y, and Z directions, but also we are doing it using neural networks. And then we have a spindle health monitoring using this accelerometer, that is vibration sensor. You can measure the what is the amplitude in X, Y, Z direction, how much vibration is there, and what are the faults present in the machine. That also it will display here. And the third one is the energy monitoring. Today is Saturday, we are not working, that's why it is machine is off. You may not able to see the run information. Here you can monitor the energy, you can machine current, you can monitor machine power, machine energy, and you can also check here part quality. As I shown the vision camera, that camera, it will be, this component will be keep moving in the conveyor. It is an automated solution where it measures the diameter of 2 holes and it measures the pitch, and if within the tolerance, then we say that this is pass, otherwise it fails, and it will generate a report at the end. This is a small demonstration of how to convert legacy machine into IoT smart. Then my second topic is also over. I'll be moving to the third topic, that is the smart manufacturing demonstration and development cell. This is a government of India initiative. As I mentioned, in India, only 2 to 5% of the machines are connected. Okay, there is a huge scope for all the people to make that 98% of the machines to be connected. That way, each industry will get benefit with respect to the industry 4.0, with respect to the productivity, with respect to the maintenance, with respect to the speed to the market, and finally flexibility to adapt to the new technology and increase the variety of jobs what they can do, variety of products they can do. And the government of India has identified 4 centers for this industry 4.0. The first one is IISc Bangalore, second one is IIT Delhi, third one is CMTI Bangalore, fourth one is Kirloskar Pune. Our basic job is to provide awareness to the industries on industry 4.0, and also we need to demonstrate workable demonstrations. Basically, we need to show the real-time smart factory to the industries so that they will understand what are the challenges and implementations while implementing this industry 4.0. And also we also need to make industry ready engineers. For that, skilling and reskilling also we are offering programs. We take interns. We also provide MTech projects to the academic institutes. And what we generally do is these are the 5 basic objectives what we are doing in SMDDC cell, that is smart manufacturing development demo cell. The first one is the industry 4.0 implementations, wherein initially we also doesn't know about what is industry 4.0. What we do is we buy some ready-made solutions and we implement those solutions in the factory. That way we will understand what are the implications or challenges in implementing those modules in the factory. The second one is we also need to collaborate with the industries so that we can solve their problems in this project. We have associated with Indian Machine Tool Association. We associated with Siemens R&D. We associated with the MSME, that is for a smart spindle. We associated with Utunga, it is an IoT solution provider, and we associated with Hexagon Metrology for smart measurements. And we also need to establish one smart factory wherein where that is a workable factory without any operator. The machines should run on its own. That also we are trying to make an attempt by next March, that is 2021. The factory will be ready, and as I mentioned, we need to provide lot of training to the people and also provide awareness courses to various industries and small scale industries. And whatever solutions we develop, that solutions we try to give it to government establishments. We have submitted 2 to 3 proposals to Indian Army, then ordnance factories, and then micro scale medium enterprises. And we are also trying to develop in-house some R&D projects using project fellows, students. These are the industry partners. Each industry partner we have identified uh, their problem. Actually, industry partner comes with a problem, something like smart spindle. We try to help him to develop both mechanical, electronics, and finally make a smart spindle and give it to him. In this, he spends 20% and government gives 80%. That way, with the Utunga technologies, we are working on IoT enabled technologies and machine connectivity. How to take the information from the machine, that is called machine connectivity. That also we are working with the Siemens R&D. We are working on digital twin. Digital twin is it is going to be the booming field in the future. And coming to the Hexagon, we are working on smart factory and digital twin of smart factory. And with the Indian Machine Tool Association, we are working on a smart factory demonstration. This is the smart factory layout. What I was mentioning, that in 1 minute time we need to able to show this. Here the truck is bringing the raw material and coming to the loading and unloading station, and using this automated guided vehicle, it is going to the first machine using a robot terminal center, and it is going to the second machine again using a robot to the vertical mill center. Then it is going to the grinding machine, then shorting, then comes to another machine. Then here it will go to the washing station like deburring station and go for the measurement. Once the measurement, the component is accepted, it goes back to the unloading station, and the item will be shipped to the supplier. This is a whole concept what I was mentioning. This is a smart factory what we are trying to establish at CMTI. You can see here the what is very important here is data. This is whatever each machine, you can see there is a Wi-Fi symbol. The machine is keep pushing the data, and that data is going to the master controller, one for giving the information to the machine, writing programs to the machine, and also understand what machine is doing, live performance you can see. And we also take the real-time information from the machine and give instance to the maintenance engineers to prepare or plan for the maintenance. All that activities this master controller will be doing it. And these are some of the events we have done last year. Initially, we started to provide awareness programs across the country. You can see here almost entire India we have covered: Rajkot, Hubli, Coimbatore. And then we also conducted national seminars and conferences where we invited all the industries across the country and taken the stock how to take this industry 4.0 forward with the Indian government. Then we also conducted national conference on smart manufacturing. And coming to the training programs, we have conducted to government establishments for ordnance factories, and we also conducted Industry 4.0 training program to British High Commission. These are some of the R&D projects what we have developed. All these solutions developed by interns. They stayed only for 2 months. With the help of BTech final year students, we could able to develop all these solutions. I will be showing the dashboards. so that you will get to know how those modules can be developed. As I this is, if you when we started, we are also very new to this industry 4.0, and my simple idea was how to take one sensor data to the cloud, and from there how to represent the data beautifully through app, something like that. I had a plan, but this is finally we made one solution that is called as energy monitoring. In this energy monitoring, you can see that we just mounted one current sensor, and using these energy calculations, the energy is measured and shown here. And finally, this is the layout, what it shows. When the machine is on, it shows the machine status. And this is the meter view. It shows the current, it shows the power, and it shows the real-time energy. And also, once the measurement is done, what it does is every day it monitors the complete whole day. It monitors, and it will generate the 1 second. Then I think. Okay, what it does is it will generate the report. Every day's report it generates. I think today, yesterday. Okay, let us open yesterday's date. Okay. This is the today the machine is off. That's why the energy is 0, and it will generate the report, and it will be sent through mail. Okay. The module here is basically energy monitoring module using a single current sensor, and finally the report will be generated to the supervisor. That way he can monitor the productivity of his factory. We have developed like this 7 solutions. One, we assume that the person who is having only single machine, the person who is having 4 machines, we call it as a smart factory. Then the second module already I demonstrated to you. This is a conversion of legacy machine to IoT smart. And the third module, that is again this is for the 4 machines. This is again energy monitoring, one for the machine status, and the second is for machine productivity monitoring, and finally it also gives the report, individual machine report, how much it has been consumed, how much it could able to run for today. And this is another application where remote monitoring of machines. Okay, this is one important module where you have the machine, whichever machines you bought after 2000, those machines you can able to get the real-time data. This is called remote monitoring. Here you no need to do anything. You just connect one LAN cable and you will get all the machine information to the dashboard. Okay, that way you can get the machine information, you can get maintenance also, you can get live information of machines, what it is doing. The other module what we developed is overall equipment efficiency. Here, as I mentioned, for every company, they wanted to make huge money, but they don't know where they are wasting time and where their machines are losing the time. Then for that people, we have developed a module called as overall equipment efficiency. In this, you can see that in this you can just take yesterday's. You can see that yesterday the machine was available for 16%, and in this 16% it could perform only 30%, and finally the product quality whatever he generated only 50%. Finally the efficiency of that yesterday's work only 2%. Instead of reaching 100%, he is only utilizing the machine for the factory for only 2%. That shows that he has to improve a lot. Okay, and coming to why he could not do it, that you can see he lost, that is overall equipment efficiency loss, wherein he studied, see, and you can see the actually he wasted a lot of time in the setup time itself. He did not do any job. He wasted huge time in the break itself. He started somewhere production in the afternoon somewhere at 11:30 and 12:40 he stopped it. Okay. This is another IoT solution. All these solutions were done by BTech students. Okay, then during this COVID, we developed a small ventilator. I will play that video. There is another small application what we developed, that is the mobile operated low cost ventilator. Why we have done is during this lockdown time, we thought that getting a display systems would be very tough. For that reason, we developed a small module so that everybody will have mobile, they can able to operate this low cost ventilator with a mobile. But again, it is the prototype development what we have done using ambu bag concept. I think you would have seen a lot of videos like that in YouTube. Likewise, we also made this solution. It would cost around 3 to 4,000 rupees. Very low cost ventilator. And these are some of the solutions. All the solutions were done by final year students or passed out students. Okay, it doesn't require any kind of expertise, because nowadays information is available in internet. Only thing is you need to put determined effort to make this kind of solutions very fast. This solution, the low cost ventilator solution, we made it in a single day. One whole almost 24 hours it has taken if you put together. Okay, within 24 hours, this entire solution has been made with the help of hardware node MCU. The respect to electronics and software, what we have spent is just 325 rupees. That's it. We can the entire solution, whatever I told, the ambu bag was 1500 rupees and mechanical slide was 1500 rupees, and this was just 500 rupees. You could able to do it. The entire thing, that's why I told it is 3,000 to 4,000 rupees. And I no need to give explanation about what each module consists of. Anyway, you have seen the demonstrations, IoT solutions, what we have developed, and these are all explanations for that. In some cases, we also work on the hardware, because sometimes whatever you get online, like Arduino or Node MCU, may not be feasible to develop a solution. Then we try to develop the entire hardware. We design the hardware, we buy the elements, and we give it to the PCB manufacturer. There are so many PCB manufacturers are there in our country. We give it to them, we give the layout, and we give the elements, and those people assemble everything and give it to us. And this is one prototype. The same thing, whatever, this is the sophisticated hardware what we are looking, that we are developing, and we are waiting for it. Before that, we tested whether it is really working or not, and once it started working, then we develop this design and given to the person. And you may ask, sir, how you are getting all this, how we can able to develop these solutions as we are new like you. What we do, as I said initially, we buy the solutions from a third party, or whoever is the solution providers are there. We take like 3 months or 6 months or 1 year. We learn what is the functionality of this module, and later once we acquire the knowledge, we develop it. This is another. This is a Robert Bosch solution. We took it for almost 3 lakhs, but we could able to develop within 4 to 5,000 rupees. You don't need to have a sophisticated solution. You can buy energy monitor. You can buy one energy meter which is available for 4,000 rupees. Using serial communication, you can get all the parameters and you publish it in whichever web space you want, and make a dashboards. That is also okay. And with that, we can able to make within 10,000 energy monitoring solution can be given. And once you get the data to the cloud, then data analytics is a different challenge altogether, that you can do later portion. That depends on the user requirement. You can work on the data. And we also connected one metrology equipment, that is the coordinate measuring machine. And this machine, whatever it measures, it sends the data using PyWeb software. We get a automatic report generation, something like this. Here, whichever data are within the tolerance, we measure it. Whichever data beyond the tolerance, it will go for pre-machining it. This is already explained to you. This is the old machine, what I told. We converted this old machine into IoT enabled smart. And this is another 3D printer where you can give a model through mobile, and finally the model will be printed here. This is the IoT enabled 3D printer what we have developed, and we also exhibited in Imtex 2019. With this, my talk is over with respect to the smart manufacturing development cell. Till now, I have talked all the applications related to the industries. Let us understand what is this smart manufacturing and industry 4.0. Okay, I have wantedly have chosen that first to bring the curiosity to the students, that the products can be developed if you have multidisciplinary team. The second module I have mentioned, because if you are looking to develop some kind of solutions, you go nearby to the manufacturing companies of your region and try to offer solutions for old machines, because those are very good. That's why I have opted the second one. The third one is what exactly we do under smart manufacturing. That also I have covered. But now I'm coming to the basics of Industry 4.0. What is Industry 4.0? People are talking Industry 4.0 nowadays like mad. Like wherever you go, any conference you go, any seminar you go, are you working on Industry 4.0? What is this Industry 4.0? Okay, Industry 1.0 is basically, it is mechanical production happened due to steam engine. When it comes to Industry 2.0, these are industrial revolution 2.0. They have converted this mass production using electricity. When it comes to Industry 3.0, where there is programmable logic controllers, where the electronics started coming smaller and smaller, the complexity, and then any complex operations can be easily done in the third generation. That's why these computers, then programmable logic controllers had evolved in Industry 3.0. When it comes to Industry 4.0, that is the Industrial Revolution 4.0, where people are talking about cyber physical systems, where real systems will be able to give the complete information in your mobile itself. That is called cyber physical system. When this industry 4.0 ends, this 4.0 will be ending at least 100 years. It will take next 100 years to end this 4.0. Why? Because these are related to cyber physical system. The day machines work on its own without any human intervention, that day we can call it as industry 4.0 is completed. Likewise, you can take a real-time example. Now we are in a lockdown situation for almost 3 months. Most of the companies were shut. Okay, if we have achieved this industry 4.0, most of the factories would have run 24/7 without any human intervention. What I mean to say is this industry 4.0 will continue for at least 100 years. Okay, why we need it? Because it can eliminate waste, and then we can reduce the cost like anything, and the customer will get the product at cheaper cost. And then we can also make one complex solutions. Like today you have you're talking about robots, and then collaborative robots, autonomous robots. It means the robots are able to take decisions and doing the activity along with the human beings. That kind of complex jobs are doing, that is offering by the industry 4.0. And of course, if you are not industry 4.0 ready industry, then your industry may not be able to compete with other industry and the industries. And another important, what why people will go for industry 4.0? Again, it is a similar way we mentioned, that is you can improve the productivity, that is called overall equipment efficiency you can improve. And then the part quality what you produce on the machine will be further improved by adding some external sensors and transducers. And then the production will, I mean the speed at which the component comes out will be very faster, because you are using robots for high speed application, cobots for collaborative applications. And you can also increase the flexibility. You can make any kind of complex jobs, because not only human, the machines are giving lot of inputs to the human beings and coming out with artificial intelligent models. You can make variety of products. Earlier, when you look at one manufacturing company of a car manufacturing company, they will have one or two models. But today, one model may not serve the purpose of that company. He needs to come out with at least 5 to 10 varieties of car models. Then only he can able to succeed in this market. And these are some of the key terms. That is the Internet of Things. The second one is Industrial Internet of Things, Industry 4.0, and Cyber Physical System. All put together, still it is a part of Industry 4.0. Internet of Things is whatever you are doing on a mobile, those are Internet of Things. And whatever data you get to the mobile, again those are Internet of Things. Industrial Internet of Things, if IoT devices are connected to the industry, we call it as Industrial Internet of Things. And Industry 4.0 is a subset of IoT, IoT, and cyber physical systems. And there are some elements of it. Whenever you are planning to get into industry 4.0, you need to do vertical and horizontal integration. This is very important. What is this? Let's talk about this. Physical systems are nothing but machines, robots, or your assets. These assets, using some sensors and actuators, you have to collect the information, and you through some electronics, something like edge controllers, or some analytical software, something like LabVIEW or MATLAB, do some analysis. And once you do the data analysis, you give it to the device management, where it collects all the information of your assets. And finally you give it to the data service. These people will try to do some data processing, then give it to the analytics service, where they do exactly big data analytics. And finally they use it for applications, whatever you're seeing, Ola, Uber, all these people, they will be making some models here, and finally they use it for their business. Okay, this is a complete layer, physical layers present in industry 4.0. You have physical assets, you have electronics, you have a communication, and you have data, like taking it to the computers, and finally do some big data analytics, or some data, I mean machine learning, those analytics you can do here, and finally you use it for your models. How effectively, like if you look at McDonald's, how they are arriving at the prices, even the owner doesn't know how they arrive, because these are all analytical models. Okay, based on the data what they collect for last 2 to 3 years, these models will be dynamically changing. That's why the price of the item will be completely decided by the models, and finally they use it for the business. And what are the 6 design principles of Industry 4.0? One is interoperability. What is this interoperability? The ability of cyber physical systems, humans and smart factories to connect and communicate with each other via Internet of Things or Internet of Services. And then you need to visualize your whole factory, how it is looking, and each machine you can, in your mobile itself, you can see what is the status of the machine, what it is doing, and is it going to fail in 1 or 2 days. All that virtualization you can able to see. And the third one is decentralization, the ability of cyber physical systems with smart factories to make decisions. As I mentioned, this Industry 4.0, it is not going to end in a near, it takes very long time. The decentralization is a very, very important concept. It takes a long time. The day machines become more intelligent, autonomously they take decisions, then only we can call it as a decentralization. It takes its own time. People are, a lot of companies are working on decentralization. And coming to real-time capability, that is, you want to monitor the production monitoring of a factory. If you take single example like Maruti, they'll be producing almost 10,000 to 20,000 cars in a day. Those people, they need, and each car will have 1,000 components, 2,000 to 1,000 components, like 20 lakh components monitoring, because again each component will be going for 7 to 8 processes. Okay, following the each process is going to be critical task, but today due to this Industry 4.0, they are able to follow each and every activity of that particular component, where it is, what process it is going on, and finally what would be the end product, that is a car, when it will be assembled. To that level, people are able to get the real-time capability. Then the service orientation, of course, due to this, when service we can able to provide, a lot of people already doing that today. Using this Internet of Service, we are able to communicate and present the talk via virtually, that is called as IoT service. And modularity, because of this, you can you can able to do variety of components. Earlier, if you see that, if you go to any Maruti plant, if it is Maruti 800, then you can, in that plant you can only either assemble Maruti 800 or not. But today the same assembly line has to do for 10 to 20 variety of cars, then only he can able to uh, do the justice for the capital investment. And what are the building blocks of Industry 4.0? The building blocks of Industry 4.0 is autonomous robots, and as I mentioned, the big data analytics is going to be a disruptive technology. And then augmented reality, people are using it for maintenance applications, and additive manufacturing is also going to be the disruptive technology. At the moment, people are seeing additive manufacturing only plastics, but once metal additive, the cost comes down, people will be, this technology going to be revolutionize all the CNC machining processes. And then you have cyber security, when you can make solutions like, I've mentioned that we have proposed few solutions to Indian Army, but their concern is the cyber security, because all these modules, whichever you take it to the cloud, the cyber security is one of the major concern. Anybody can take the data. As I mentioned, data is the key. You need to protect the data. All this, if you are attempting any solution to develop to defense or navy or army or atomic energy, the cyber security will be one of the greatest concern. People can work on cyber security as well. Then you have industrial Internet of Things. Earlier, people used to make only the sensor, but the sensor alone you cannot sell in the market until unless you make a sensor with wireless communication, then only people would be looking at that sensor for industrial application, that is for IoT. Then as I mentioned, horizontal and vertical system integration. Whatever elements you use in the factory, somehow that element give the status information. Then only the factory becomes completely industry 4.0. This is the industry 4.0 environment. It is not just machines should provide the data, your building should provide the data, your home should provide the data, your web social web should provide the data. This is a complete, everything has to be smart, then only we can call it as industry 4.0. And again, these are the same technology pillars, that is autonomous robots. Today we call it as collaborative robots. Then augmented reality. Today augmented reality is helping a lot of applications related to maintenance activities in industry. And as I mentioned, there's a horizontal and vertical integration. It means that whatever element you use it in the factory, it somehow you should have a way to send the data. And then you need to, every device what you use, it should have a way to communicate. And then cyber security is very important. Cloud storage. Today, a lot of cloud solution providers are there. Amazon to hosting small companies, many are there. You can make use of those people for the service and develop the solutions. And additive manufacturing is one technology pillar. And finally, whichever suppliers you are buying the raw material, you are buying the tools, or you are buying the machines, all those people should have a method to directly communicate to your factory without any human intervention. Then we can say that this industry 4.0 is coming. And what are basically challenges? It is everybody is dreaming to be the part of industry 4.0, but the problems are there is no standard. Suppose if a person wants to get into the manufacturing and he wants to start his own company with industry 4.0 ready, so that he can get the lot of market. The problem is the standardization. He cannot just like that get into the industry 4.0 because there are no standards available to start a industry 4.0 industry. And your the in some places where already industry is interested, but your organization may not be having the expertise to adopt this industry 4.0. And some people, they say that we don't have available products. Some people say that their business model may not allow them to get into industry 4.0. Some people mention there are some security concerns. Some people, they mention that lack of labors, the workers, they are not able to get into industry 4.0. Some people say that a lot of research is required to get into industry 4.0. Some people say that a lot of professional development should happen, then only industry 4.0 happen. These are some of the technological challenges people mention when they want to adopt this industry 4.0. And this is a small research, a Bitcom research what they have done. They conducted a survey, and out of 10 companies, this survey has happened in US and Germany. Out of 10 companies, only 4 companies are adopted industry 4.0. Reasons they mention why they could not venture. Reason is the investment is high, then shortage of skilled professionals, and then there are no standards available, and there is another security concerns because you are taking everything to data to the cloud. Okay, and that is one concern. And finally, unclear economic advantages.
వాడే
What
స్టేజ్
benefits they
బుక్
are not getting.
బుక్ కాడ కాదు మనకు కిట్ ఇచ్చలే వాడే సీడీ చేసేది.
And this already I showed you. You can see which industry, who is using industry 4.0. You can see this. Almost electronics industries 45% they are using it. You name any electronics industry, Siemens, Panasonic, then Apple, all these people adopted industry 4.0. And aerospace 22%, industrial manufacturing, chemicals, transportation, logistics, engineering and construction, metal additive and automotive. But in 5 years, people are predicting almost 70% of all these sectors will be converted into industry 4.0. From this survey, what we can say that industry 4.0 is going to be the booming field by working on multiple technology pillars, whatever I have mentioned. And you can also see that what are the topics if you want to get into any industry, which topics people would be interested. Something like this: digital factory logistics, they're using then predictive maintenance, people are using this industry 4.0. Then electronic performance boards people are using, mobile and real-time performance management they are using, smart shop floor production control they are using, augmented reality for training they are using, autonomous robots they are using, social business media they are using. This is for both Germany and United States it is mentioned. And how to catch up this industry 4.0. Okay, suppose if you buy a latest hardware which provides all the information to you, still you may not get the complete benefit from the industry 4.0, because the industry 4.0 is something like an evolution. Okay, you need to create a history of data, then only you can make nice models, then only you can make some kind of analytics, some kind of history of data is required, then only you can able to take some wise decisions. That's what I'm trying to say. In the beginning of industry 4.0, what you should do is ensure that all the devices whatever you are using in the factory, those somehow you get the data, connect to gather all the sensors data and collect the big data and keep it that information. In the second stage, what you can do is you try to add some intelligence for that, using some artificial intelligence for that data you apply and come out with some models. Then once you have a model, you try to do some predictive what is going to happen, because you found that something is going to happen, then you need to be able to look for predictive capability. You need to make some kind of knowledge base and some kind of, and finally decision making is very important, because everybody will have knowledge but decision making will lack, because that is another important thing. This is a very important aspect that is called autonomous action. The day machines take decisions on their own, then we say that our involvement is not required for that. Okay, that is called industry 4.0 vision. Okay, we wanted from a value to industry 4.0 maturity, it will take at least 100 years. And what are the disruptive technologies? What is a disruptive technology? It can change the whole scenarios. Okay, like I'm working as scientist, my growth may be limited with respect to the research community, but when you work on this disruptive technologies, okay, the growth of a person will drastically change. The applications whatever it comes out and the models which comes out, it can revolutionize the company, it can change the fate of a person, company, and then organization. Okay, this the in terms of disruptive technologies, big data analytics is going to be the booming field. Then digital supply chain is the second followed. Then Internet of Things is the third. Cloud computing, advanced robotics, machine learning, then 3D printing, drones and self-guided vehicles, and the sharing economy. These are the disruptive technologies. And if you look at the jobs in industry 4.0, you can see what are the skills they'll be, I mean, which fields they'll be looking for. One is for the data management, data security, software development, programming for automation like robots, then PLCs, then integrated systems, then data science like big data, then analytics. This analytic is a key. People would be uh, looking for this. It requires a core expertise as well as analytical expertise. Then people will be looking for human machine interface, machine to machine and machine to part communication experts. Here communication engineers would be preferred. Then control of manufacturing process, here electrical electronics persons will be involved, and development of manufacturing processes where mechanical engineering expertise is required. Then operations of machines, here again mechanical stream professionals will get benefit. And finally manual processing and work, this is technicians would be benefiting from this. And what is going to come in coming years? In 2020, we expect 26 billion internet connected devices would be happening. By 2025, around 3 lakh drones, 30,000 drones will patrol US airspace. And 2029, computers will be clever than humans, according to Google's director of engineering. And by 2035, we'll have 11.8 million self-driving cars. Then this is the digital twin. What is a digital twin? You have a physical device, and when you can able to get the complete information without visiting to that physical device. You can get all the information of the physical device in your tablet, and you can see the entire and you gather all the information without mounting any sensors physically. And with this, I'm done with my presentation.
Thank you, sir. I request all the participants who are raising your queries, please raise your queries in chat box, or else you can unmute yourself and ask the speaker.
When somebody says that ask questions means it is basically an opportunity. You have to take those opportunities, then only you can excel. Pradap, any faculties are there?
Yes, sir. Yes, sir. All the faculties are here, sir.
Okay.
I request again all the participants, if you have any queries, please ask to the speaker.
At least I just want to know whether my lecture is relevant to the students who attended or not. Maybe you can talk on that.
Narendra. Hello.
Raja. Tell me, Raja.
What are the skills required relevant to Industry 4.0?
What are the skills?
What are the skills required relevant to Industry 4.0?
Yeah. For Industry 4.0, as I mentioned, it is a multidisciplinary field. Okay, if you are a mechanical engineer, you can be comfortable with any design software, that is fine. When you are an electronics engineer, then you can work on some edge controllers. If you have some embedded expertise, that is sufficient. For a computer science, you need to have knowledge on database, and then like PHP, SQL. Then you need to have Python programming experience. This will be sufficient to.
Then how to turn a regular industry into a smart industry?
How to convert?
How to turn a regular industry into a smart industry?
first thing what you need to do is whatever that industry is doing, you have to list down all the activities, and you ensure that all those activities you need to convert from manual entry to a digital form. And whichever machines or devices you are using, somehow those devices and machines has to give the data to the system. Then you can do something. Okay. First, you try to convert those machines to give the information digitally. That is the first step.
Okay.
Hmm.
Okay. Thank you. Again, you are introducing low cost ventilator. The low cost ventilator, how long can a person stay on ventilator?
Yeah, this is just a prototype what
How
we
long
have shown
can
here.
a person stay on ventilator?
This whatever I've shown.
Yeah, yeah.
This is
Narendra, my voice is clear.
what is that?
Yeah, yeah.
Yeah, voice is clear. Voice is clear.
How long can a person stay on ventilator?
That is a very generic question.
Hello.
Yeah, ventilator
Okay.
depends on the person. Basically, ventilators are supposed to work 24/7 for 14 days. Whichever equipments, whichever ventilator
Okay.
equipments are there, medical hospitals, all those hospitals, ventilators work for 14 days continuously with the 24/7 operation.
Okay.
Okay, our ventilator,
Okay,
whatever
good.
we made, it works for about 4 to 6 hours continuous operation.
Okay. Yeah. Yeah, yeah. Can you die while on a ventilator?
Can you? Yeah,
Can you
people.
die on a can you die? Can you die while on a ventilator?
Yeah, many see if you I don't know whether it is the validated information or not. Most of the popular leaders, even after death, they will be kept in a ventilator
Okay.
for 4 to 5 days. To sometimes there are least
Okay.
possibilities that they may come back to life. Okay, mostly
Okay.
ventilator.
Okay. Thank
Once
you.
the person goes to ventilator, only 2% chances are there to be alive. Otherwise, 98% chances are nil.
Okay. Thank you. Thank you so much.
Hello,
Yeah.
hello, sir.
Pratap Chaitanya, please respond.
Yeah.
Pratap Chaitanya. Yeah.
Hello, sir.
Sir,
Hello.
sir, tell me,
Hello,
sir.
sir.
Chaitanya, please ask the questions. Please ask the
Sir,
questions. Those who are in, yeah, Chaitanya,
Hello,
please.
sir.
Yeah, tell me. Somebody is talking. Hare Krishna.
sir, a question from
Yeah,
student.
yeah.
So, how this webinar is useful for CSE students?
As I told you, all these solutions, whatever I shown here, IoT solutions, these were done by computer science students. See, if I ask this work to do a mechanical engineer, he cannot do it because he doesn't know how to do HTML programming. He doesn't know Python programming. Okay, these solutions were made by computer science engineer. Not we know what is happening inside, but the entire dashboard design and backend programming was done by computer science students.
Hello, sir. Hello, sir.
Hello? Yeah,
Hello,
tell me,
sir.
sir.
Sir, when we get
Yeah, who is that?
certificate, sir. Sir, I mean Chandrasekhar.
Oh, yeah, please ask.
Sir, when we get certificate, sir.
Pratap, you please answer.
Hello?
Hello, sir.
Hello, brother. You can get certificate by filling the form what we are giving you in WhatsApp as well as in chat box in GoToMeeting. Okay?
Okay, sir.
Okay.
Sir, Good noon, sir. My question to you, first of all, it was a very wonderful presentation, sir. We got to know a lot of things regarding the Industry 4.0 and smart manufacturing. I'm basically a mechanical
Yeah.
engineer. So my question to
Yeah.
you, sir, is, am I audible, sir? Hello?
Audible. It's clear.
Hello?
Go ahead.
Yes, sir. Yes, sir.
It is very
My
clear.
question
Go
to you
ahead.
is, sir, yes, sir. My question to you is, how could have Industry 4.0 or smart manufacturing, what we call, could have helped in fighting the pandemic? How better it could have been in helping the situation to overcome the COVID-19 pandemic, in the
As
situation
I
like that?
mentioned, now today you see that why we are opening lockdown. See now government has eased the lockdown, right?
Yes, yes. To revive
Yeah.
the economy.
If Industry 4.0 is completely functioning in the country,
Hmm.
the manufacturing companies, because
Hmm.
the huge manpower
Hmm.
in India is working in manufacturing domain. Okay, all because we are talking about all these workers are working in manufacturing companies.
Yes,
These
sir.
people wouldn't have affected much if the industries are running through Industry 4.0. Okay, like Germany and US, you see, even though the even though the even though COVID situation is very bad, but the economy is somehow stable. But in India, due to economy, government is in a very confusion state whether to open the lockdown or should we continue lockdown. But whereas other countries, their economy is not much disturbed. You can look at their indexes; they are completely okay. In fact, US is all-time high with respect to the markets, share market. That shows that they did not affect much with respect to the pandemic, with respect to economy. Of course, they lost 1 lakh people life, but the economy did not disturb much. Like India, we did not adopt this Industry 4.0, because of which government is worried about basic necessity and companies are worried about economy. That way, government is in big confusion how to handle both economy and life.
Okay, sir. Thank you. My second question is, uh,
Yeah.
sir, how or what will be the expectations, or what will be the things that will be involved in the future Industry 5.0, if there is any case like that?
That's what I said. No, the day machines becomes like who they take autonomous decisions on their own, then
Hmm.
our involvement itself will not be there. Okay, that time machines decides that Industry 4.0 is
Hmm.
nothing but if Industry 5.0 has to come, the machines will decide what they need further. That is,
Hmm.
we cannot decide. We cannot decide Industry 5.0 based on our this one. Industry 5.0, what people were saying is there won't
Hmm.
be any technology like Industry 5.0. It is something like a society, love and affection kind of thing. It is a social. Now today we are seeing due to this pandemic, these people were very affected towards kind, lovable. All that is happening. That kind of societal enlightenment will happen rather than this technological development.
Hmm. Hmm. Okay. In the Industry 5.0. Okay, sir.
Yes. Yes.
Thank you. Thank you. Thank you.
You can ask me some questions also, need not to be on presentation, because I have limited my talk with respect to my work and Industry 4.0. But if you have any generic questions related to career also, I would be happy to answer. Because now there is the uncertainty about our career, right? Because most of the companies are worried whether if this COVID continues for longer time, something like 2 years, at least 30 to 50% of jobs will be in a critical situation. Okay, then that's why we need to be very competent enough to get the opportunities. Okay, anybody ask you the question, it is always you should lift the hand to ask what I should talk, or you can ask what is the question. Like that, you should be proactive. Then only you can able to survive in the present global market. In simple illustration in a class, if your lecturer asks, do you have any, who will answer this question, means you just lift the hand, then only you ask question. Sometimes we may miss what he has asked also. Still you can lift the hand and ask a question. Like that you should.
Sir,
Sir,
is there any connection between IoT and cloud computing, like API key for accessing the websites?
There is a connection. Now, okay. This entire data, whatever I shown here, this data will save it in a cloud only. Wherever we wanted to do very quick data, I mean in milliseconds or microseconds, then we doesn't do analytics after cloud. We try to do before in the cloud itself. Wherever in seconds you want to do, then we try to do after cloud, we do analytics, or in cloud also we can do analytics.
So not a particular company, but we want to give the information to other companies. So we use any key.
That I'm not sure. There are some open sources are there. No, you can give to multiple people the same data.
That means a particular company information will give to any other company if they want. So is there any API key like that?
That I don't know, Pratap.
Okay, sir. Thank you, sir.
Yeah. Any other questions? General questions also I'll be happy to answer for related to career. Regarding this computer science, I cleared that question, because without computer science there is nothing like industry 4.0. They are like in the top layer, they only will be there, dashboards, then cloud, database, and then analytics, data analytics. These people only are helping at the moment. And if you don't have any questions, I wanted to give one suggestion how to get this industry projects. Everybody will have this doubt in your mind, both faculty as well as to the students. See, for me, the suggestion is when you are in third year, you try to do projects within the campus. But when you are in final year, try to solve some regional problems. Okay, in and around your college, there would be some industries, or there is a society like agriculture or something. You try to solve some engineering problems to the society or to the industries. Regional problems you solve. That is going to revolutionize your career. I'm not worried about MNC to grow. I'm worried about individual to grow. If individual has to grow, try to solve regional issues using your engineering expertise. That will give you MNC job, and that will give you satisfaction, that will give you more motivation to your engineering.
Sir,
Okay, that's it from my end actually. You can.
excuse me, sir. Sir,
Kavya, are you talking or you are talking to your parents?
Yes, sir, I am talking to you, sir. Sir, my question is, which stream of engineers majorly get benefited on learning about smart manufacturing, sir? And please explain the other ways to further learn about smart manufacturing, sir.
Yeah, I told you no. Okay, 1 second. I just opened that. Then you will get an idea. Now, you can see here now. Here you can see this is the purely big data analytics. Both the electronics person can do, computer science person can do, because it requires only the analytical knowledge. When it comes to augmented reality, here also computer science student and electronic students will come into picture. When it comes to additive manufacturing, it requires some kind of mechanical expertise, and if he's working on the process. If he's working on developmental of additive manufacturing, then computer science, electronics, and mechanical will come into picture. When it comes to cyber security, only computer science people will get benefit from it. When it comes to industrial internet of things, here electronics and electrical will come into picture. When it comes to horizontal and vertical system integration, here communication engineer will come into picture. When it comes to simulation, electronics, computer science, as well as mechanical, all three disciplines knowledge will come into picture. And here finally autonomous robots, both computer science and electronics and mechanical people will come into picture. One thing I want to tell you, over the time only you can acquire the knowledge, but the beginning, if you want to get into, you can get into any fields of your domain. Over the time you can become a multidisciplinary engineer, because in the college whatever we learn, it is just surface level we learn, surface knowledge only we get it. But when you go to the depth, that time only you will understand to solve the real challenges. Okay, that time you need at least 5 to 10 years of experience. That's why people always say that you should have a long term goal rather than short term goal. Okay, once you start your career for first 2 years on some area which you wouldn't have interested, then your career will not be so smooth. Okay, I advise all people, you find a long term goal rather than short term goal. Did I answer your question, Kavya?
Thank you, sir. Thank you very much.
Welcome. Some Khyati, it seems. Which languages should be known for us mainly? Okay, 1 second. I just show you what languages. Python is required. Then 1 second. Okay, I think this is one small module there we have mentioned. This is one intern. I mean, that is the final year student has done that. He used for one module. This is, I don't know what module he has done, but he has used MySQL, PHP, JavaScript, and then C# is required. And finally, for report making, he used a PDF make.
Okay, sir.
This is for Kathy. Any other questions? And I will ask questions if you don't have. You are all engineers, know what you did during this lockdown time? Please answer, because anyway you will get certificate. Your job is done. Because now information is available freely. Lot of YouTube videos are coming socially. You could have made some small equipments, some small hand sanitizers, or some uh, touch, which one, contactless sanitizers you could have made. Because you are all final year engineering students, you need to have a motivation to contribute something to the society. This is a great opportunity. Okay, if you have not done anything, at least if, because this pandemic means how long it will continue, nobody knew, and how it government also doesn't know how to handle it. But still, you just think about alternate ways to give some suggestions or make some models or make some prototypes which can help for the uh, pandemic. Okay, if we don't have any questions, we can wind up, Pratap.
Yes, sir.
Pratap Chaitanya.
Sir, wait for a while, sir.
Yeah.
Yeah, please respond, Pratap Chaitanya.
Sir.
He responded, Raja.
Hello.
Yeah,
Sir.
tell me, Raja.
Hello, Narendra. Please,
Yeah,
please wait
listening.
for 1 more minute. I think it is time
Sir,
to.
wait for a while, sir.
Hello.
Sir.
Narendra means Pratap Chaitanya. Please give me vote of thanks.
Sir, yes. Yes, sir, yes, sir.
Who is?
Yeah, I think.
Yeah.
I sincerely thanks to our dearest speaker, Mr. T. Narendra Reddy, sir, for giving a valuable lectures and spend your valuable time with us. And behalf of our EC department, we would like to give you a honor of appreciation with a certificate. Here is the certificate for you, sir. Thanks for your valuable lecture.
Thank you. Thank you.
Okay, sir. So it's time for vote of thanks. So I would like to thanks our speaker, Mr. T. Narendra Reddy, sir, for coming and learn us something new aspects, which is especially this trending industry 4.0 in this pandemic situation, how this will be useful for us. And I would like to thanks to our college management and our principal, sir, Dr. M. Manoj Kumar Reddy, sir, and our beloved HOD of EC department, Mr. N.V. Subba Reddy, sir, and our convener, Mr. A. Dastagir, sir, and our co-convener, Mr. P. Raja, sir, and all the faculty members of EC department. And at last, I would like to thanks for all the participants for making this event successful. Thanks to one and all. Thank you, sir.
Thank you so much. Yeah.
So all the participants will please fill the form which is provided in the chat box of GoToMeeting as well as WhatsApp and Telegram group. So you will get a certificate. Wait for some time.